Okay, we will create the following 3D model using Catia V5. As you can see, what we have right here, it's basically this profile extruded along this direction with a hole right here, and right here. So this is hole right here, and right here. And extruded within this hole, we have this circular shape with a through hole along this direction. That is pretty much it. So we're going to start by analyzing the two things that we always do. The first one, the unit system that the engineering draw is using, and the second one, the information within the views. Now, this engineering draw was made by Luis Miguel Huerfano Garzón. I was able to identify some different mistakes done with this engineering draw. The first one, I cannot see any information within a box regarding the unit system, the name of the part, the material. This is like pretty crucial information for when you want to manufacture a part. As well, this means that the normativity for you to create the views, you can use either this one or this one, but not the same at the two of them at the same time. So this is a mistake as well. This is not showing me, as I mentioned before, the unit system, the millimeters, meters, or inches, feet, whatever. This is not a mistake. Why is that? Because although it is necessary for you to eliminate any type of error during the production, if you don't find that information within the engineering draw, you can assume that you are working in millimeters, alright? Now, I'm going to start by, let me see, as always, we always start like using the view that contains the most information possible. This is the view that contains the most information possible, although this is not a view. This is an auxiliary view. As you can see, this is the only view that we have. As well, we're going to take into account the isometric view. Now, because of this is the unit, the only view that we have, we're going to start creating the shape that I mentioned before. Alright, now taking into account the 58, 12, 35, and let me see, 82, because it is necessary as well. Now, we're going to start by using our software, so click on File, New, write down Part, Enter. This is our tutorial 26, I think. Enter. And now we have access to the Catia V5 part design environment. Now I'm going to click on a sketch. I'm going to select the lateral view. That means the YZ plane. And I'm going to start drawing the profile that we have right there. So it looks something like this, I think. Yep. Right there we have it. Now, we're going to define the dimensions that I just mentioned. So this one, and the 35. And as you can see, this is still showing me some parts or some lines in white. Now, this means that this is not correctly defined. Everything should be in green. Now, let me see what is happening. Okay, I understand. Now, as you can see, this point has to be at the same vertical line with this other point, right? Now what I'm going to do is that I'm going to create an auxiliary line for construction purposes, connect the two of the points, and then say that this line has to be vertical. Alright, that is basically it. That is basically what I've done. Now, I'm going to change the values of the dimensions. As you can see right here, I'm working in millimeters. If you cannot see the correct dimension, then you have to click on Tools, Options, Parameters and Measures, Units, and right here we have the unit system. Now, I did multi-constraint. As you can see, this is showing me in orange the value that I'm changing. So this is 35. The next one is 12. The one that follows is 82. This is 12 as well. And finally 58. Okay, and okay. Right there we have it. Now, we are going to extrude this, but first I'd like to show you some different mistakes that Luis Miguel Huérfano Garzón made with this engineering draw. The first one. As you can see, this auxiliary view is created regarding or taking into account this arrow. As you can see, this is says vista N, which in Spanish means view N. Alright, so it is like if you were right here watching the part along this direction, and if you do that, you're going to see this. Alright, now why this is a mistake? Because I was able to speak with a person who made this, and as you can see, this is the arrow of N, for example. Now, this is created taking into account this plane. Alright, let me see right here. I think it's better. Yep, because he wanted to show how this would look like if you, like I mentioned before, look at this part from this point towards this direction, right? So you can see this clearly, correct? Now, this is correct for when you want to show this part of the engineering draw. But what happens to this? That these measures are not correct. Alright, because you're going to see this part with a 35 degrees angle of error. Why 35? Because right here we have 35 as well. Sorry. The same one that we have right here. Right, if you want, I can check that right here. So this is with a 90 degrees angle, the view. Now I'm going to select this using the Control key. This has to be perpendicular. Now I'm going to extrude this line a little bit more, and finally I need this angle. Sorry, Control C. need this angle. So when I speak with him and I explain that this was an error, he mentions that these values are the ones that you can see when you look at this at the part like this, right? But as the way he's creating this, he is saying that these values are the ones that that are shown when you look at this way. And that's an error, guys. We're going to maintain these values as if we were watching at this part like this. But remember, if you want to show that you're looking this part from this point towards this direction, then you should create another auxiliary view. And as you can see, we have plenty of space for us to do that. Alright? Now, continuing with the exercise, I think that I made my point pretty clear. I'm going to insert this. So I'm getting out of the sketch, the path definition tool. I'm going to use this information, and this is another mistake, guys. You cannot over constrain the view. For example, this is telling me that this radius is equal to 12 millimeters. This is telling me that right here I have a 28 millimeters dimension. That means that this is symmetric, correct? That means that right here as well I have 12 millimeters. Now, 12 plus 12 is equal to 24. Plus 28 is equal to 52. Alright? The same 52 that I have right here. So, this is not correct. This is correct. This is not. Because I'm perfectly capable of assuming that because of this 52 right here I have a 12. And right here I have as well a 12. Alright? Now, I'm going to store 52 millimeters. Enter. And basically I'm going to start designing, taking into account this face. Now, right here we have this part, and I'm going to call this line using the projection tool, project 3D elements, but I want those to be projected with construction purposes, so I'm going to select this tool, and I think that I'm going to take everything, all the edges. Okay, now I'm going to create a circle looking at the middle, or I'm looking actually at for the middle of the part, so right here I have it. Escape. As you can see, this is showing me like a circle with no filling. But if I stop at the middle, it is showing me a black, completely black circle. Right there we have it. Now I want it to be created for me to eliminate the part, so I'm going to select it and select this tool. Now I'm going to do the same thing right here, but I want to create a symmetry line right here. Now I'm going to define the circle. This circle is 15 millimeters as its diameter. And I'm going to say that I need a mirror with respect of this symmetry line. And finally, I'm going to say that between these two I have 30 millimeters. As well, the dimension between this part and this middle point is 30 millimeters. All right. Now, this is as well a mistake. I didn't need to evaluate this 11 because it was not necessary. So, you don't need this. Now, if I want to create this, I assume, I don't know, this rectangle, the correct way, if I were given this view, is to create it within this view that I'm actually at right now. So I would take this part, create a rectangle, say that between these two lines I'm going to have a symmetry line, which is this line. And finally, I'm going to define it like this. So 26.213 and 28. This is the correct way, although it is not the correct way. This is the way in which the engineering drawing is telling me that the part has to be manufactured. Now, this is incorrect because of what I previously said. So Control C, I'm going to eliminate this. And now, well, not Control C, let me see if I can show you why this is a mistake. Nope. I don't think so. Control Y, no. But I want to show you why this is a mistake. So just bear with me for one moment. I'm basically doing what I did before. Twenty-six point, sorry, 26.213 and 28. Now, what happens if I create a hole? The bucket definition for this. This is showing me an angle right here, correct? Now, the correct way for me to solve this is doing this other thing. And it's calling these three lines, close the profile, and finally create a pocket right here. Now, this is what we have right here. It's correct, but it is still what we have right here. Now, there is a mistake that I saw with this that I just did. And it is basically that for this instruction, the sketch that I did before, this is not correct. Why is that? Because this should be like this. And between these two, right here, I have a 90 degrees angle. And this means that I'm gonna define the angle as well right here. 35. Let me see if it's showing an error. Yep. Sketch 1. Okay. Between these 2 points, I need it to be coincident with each other. Okay. The sketch 2 is showing me an error, so let me see. Projection, delete. It was because of the projection that I previously did right here. Going to do it once again. And connect this point with this line once again. Alright, now we have everything good, correctly done. So the bucket, and that would be all. Now, I'm going to create the correct way for me to define this square. So once again, I'm going to call this line. Okay, for construction purposes, then I'm going to, Control C, locate the center of the line once again. Right here we have it. This line has to be vertical. Now, this square, I'm going to say that between these two lines, I have a symmetry line, which is this one, for me to be sure that the rectangle is created at the exact middle of the part. Now I'm going to define it. So 28 and 26.230. The bucket definition tool. Up to last. Okay. Right there we have it. Now what's left is to create the extrusion that we have right here. So I'm gonna call this circle. Going to locate the center of it and select the edge. And then I'm going to do the same thing right here, defining this other circle, because this other circle is 26 millimeters. Now, this has not been created at the exact middle of the part. As you can see, it has been created at the edge. So I'm gonna take that into account. Now, right here I have 32 millimeters, right? With respect of the middle of this, I can say that right here I have 12 millimeters. So 12 millimeters. Now, from here till here, I need 32 divided by 2 minus 12 divided by 2. Correct? So 32 divided by 2 is equal to 15, 16. 16 minus 6 is equal to 10. So right here I have 10 millimeters, and right here I have as well 10 millimeters. Now, that would be pretty much it. I'm going to extrude this using the path definition tool, mirror extend, more, okay, not mirror. The second limit has to be a dimension with a length of 22 and the other with a length of 10. Preview, and right here we have it. As you can see right here, from this point till this point right here I have the limit 2, which is this one, the second limit, and from this edge till this other I have the other limit. So okay, and that's all, guys. This is how you can create this 3D element using Catia V5. I know that this element wasn't that difficult. I know that it is important for you to, the most important for you to analyze with this exercise that I just did is the way in which the people is going to present to you the engineering draws for you to create either the 3D model or the part. So you have to be capable of analyzing everything. If, as I mentioned before, if I hadn't spoke with the person who did this exercise, I probably have created this rectangle as I did before, right? Because this is what the engineering draw is telling me. So that is pretty much it, guys. This is how you can create this 3D model using Catia V5.